Alright guys, this is going over the chapter 18 and 19 quiz, answers explained. Here's number 1, and we're going to start off with part A. So number 1 says the countries in Europe report that 46% of the labor force is female. This 46%, which you have to kind of recognize right off the bat, is that this 46% is actually telling you about a particular sample that has been taken, and that sample includes countries in Europe. It is the proportion of the labor force that's female in Europe. So that's actually a p hat. The United Nations wonders that the percentage of females in the labor force is the same as in the United States. Representatives from the U.S. Department of Labor plan to check a random sample of over 10,000 employment records on file to estimate a percentage of females in the United States labor force. So what the question asks essentially is, hey, we've got this sample that was taken over in Europe about the percentage of labor force that's female, and we want to relate that back to the United States, the proportion of females in the labor force of the United States. Well, what we've got is a p hat, or a sample proportion that was taken in Europe, and we're going to try to use that to build a confidence interval, essentially, ultimately, for the proportion in the U.S. So what they want to do is they want to estimate this, or they want to estimate a confidence interval, 90% confidence, and they want to be within plus or minus 5%. But for this particular part, they want to know how many people they should go out and sample. So the plus or minus 5% is going to indicate your margin of error. So that's essentially how close they want to be. And the 90% confidence obviously gives you the level of confidence, but it allows you to calculate the critical value for the confidence interval. So this would be how you can go find your Z star. 90% is not the Z star, but you can find the Z star, or the critical value, associated with 90% confidence. So the way that we set this up is we know that the margin of error in a confidence interval is going to be equal to whatever our p hat is, or I'm sorry, not our p hat. Our margin of error is going to be what we add or subtract to the p hat in order to build the confidence interval. And our margin of error is determined specifically by whatever our critical value is, which, like we just talked about, is directly related to the level of confidence, times whatever your, in this case, standard error is, or how spread out this distribution is going to be. So the standard error of the p hat. All right. So taking our information up here, we know that p hat is 0.46. We need to go figure out what these values are here. Our Z star, or critical value associated with a 90% confidence interval, that's going to be 1.645. And if you didn't have that memorized, which I was never a big memorization guy, we've got our normal distribution. That's a terrible normal distribution, but you guys get the picture. At a 90% confidence level, essentially we're trying to build our interval where we've got 0.05 in either tail. And so what we would have to do is inverse norm of 0.05. That'll spit out the Z-score, which is the critical value that we're looking for. And that would give us our 1.645. It'll spit out a negative if you do inverse norm of 0.05, but we know that this thing is symmetric, so 1.645 is going to be our critical value. Standard error is calculated by taking the square root of p hat times q hat. And we're going to divide that by whatever our sample size is. Remember, our sample size is going to determine a lot of the characteristics of what our distribution is going to be. All right. So what we want to solve for is n. We know what p hat is. So we can bring this stuff down. 645. P hat is 0.46. That's the sample that we got from the Europeans, times 0.54 over N. And the last piece here is plus or minus 5%, so 0.05 is our margin of error. Alright, we go through and we solve for N. We've got to divide by 1.645, so we end up with 0.05 divided by 1.645. And that's equal to this thing here. And then we've got to square both sides in order to get rid of that square root. So we'll square this side here. We're left with 0.46 times 0.54 over N. We talked about this before. Essentially, this is just algebra. We would have to multiply by N, and then divide by this whole thing. Well, that effectively just switches these two. So I can go through and solve for N by switching those two. I've got my 0.46 times 0.54 in the numerator. This whole quantity goes in the denominator. 0.05 there. 1.645 squared. Plug that into your calculator and you should come up with N equals, it's just under 269. So I got 268 point something, and we're going to round up to 269. So that should be our sample size. And again, just to put this into context, that's going to have to be, that's how many people we need to sample in order to get to within 5%, plus or minus 5% with 90% confidence.